Welcome from the IIBA Tampa Bay, Florida chapter. This is the study group for May 18th of 2023. This is our 78th class. We're going to be working on the techniques of acceptance and evaluation criteria and root cause analysis today. Our mission here at the IIBA Tampa Bay is to bridge the gap between industry leaders and business analysts by building partnerships with professionals, educators, and employers so that we may empower, instruct, and engage our BA community. We have a variety of ways for you to reach us. This is the Thursday night study group. We have it every Thursday night between 7 and 8 p.m. Eastern. You can reach our past meeting recordings here at this link that's highlighted. Cliff will drop that into the chat for you. We also have IIBA site, meetup sites, Facebook sites, LinkedIn sites. We have made it impossible for you to not be able to find us. If you need to reach out to us, though, LinkedIn seems to be the best way to reach us all. Watermark Learning has been gracious enough to allow us to use their practice study questions in our previous meetings, and so they also gave us a discount code. Tampa with a space 21 will give you 20% off of their products. They not only have business analysis products, but they have a couple of others. For business analysis, they have things like flashcards, practice study questions, classes. I don't know if they have classes in person, but they do have virtual classes and recordings. We are a volunteer-led organization. Our board is led by Cliff Gray, our president. You can see him there in the Millennium Falcon on the right. Lori, Caitlin, and Priscilla are also board members. My name is Thea Soren. I am the Vice President of Career and Professional Development for our chapter. It's my job to help you achieve your goals, and if I can help you to do whatever you need, reach out. We are still looking for new board members. If you live anywhere in the world, you can be a board member of our chapter. If you want to either use skills that you haven't used for a while, use skills that you're good at, or develop new skills, reach out and tell us how many hours you'd like to be able to work with us. Or if you'd like to be a full-time member of the chapter board, we can see about putting you into one of the positions that's available. We are a study group that is accredited by the IIBA as giving you 1 hour of education credit. And the way that we do that is we have these two folks, Bob and Yulia. Bob has his CBAP certification as well as quite a number of other certifications. He also has a website that is quite phenomenal. It is rpchurchill.com, and you can find a lot of webinars and recordings and articles there of things that are not only business analysis, but other things that are valuable to the business analyst as well. Yulia was a student in our organization, and she has now passed her CBAP as well, and she's giving back to our community by attending and helping us get the education credit for everyone else. Other people that have been participants of our study group, Bonnie, Frank, Renu, Tish, have all passed their CBAPs or tests of choice with the IIBA, and we are very excited, as many of them have told us that we've helped them. It's important to us to help them. We are one of the very few chapters that don't charge for our study group. We are here every week for no other reason than just to help people. A lot of people watch us by recording only. If you do, reach out and let us know if we're doing any good for you. And if there's anything we can do better, we want to know about it. We have been working through our techniques chapter. This is a spreadsheet of the techniques that are in the back of the BABOK. You know, there's 50 of them. Today, we're going to be going over acceptance and evaluation criteria, as well as root cause analysis. You can see that we have quite a number of techniques here that do not have anyone volunteering for them yet. If you are interested in presenting one of these, we only ask two things. Let us know that you want to do it, when you want to do it, and whenever you do present, we need you to not only present what is in the BABOK, but if you have any personal experience with this technique, for instance, prototyping. If you know how to prototype, if you've prototyped in the past, or if you just want to tell us what's in the BABOK, that's good enough. We are not asking for a professional presentation. We are not asking for professional graphics. 3 or 4 slides in PowerPoint, or just show us what the BABOK says and talk about it verbally would be just fine. maybe 5, 10, 20 minutes to get through one of these topics so that we can equip the people that are listening and who will listen by recording in the future to understand it. So whenever they take the test, they have the correct information out of the BABOK, as well as be a better BA for what they're doing on a daily basis. So now I'm going to turn it over to Bob. And Bob, which one are you going to start with? Acceptance and evaluation criteria or root cause analysis?
I don't know. Let's figure it out randomly, whichever tab is up.
Okay, I will stop sharing and I will let you have it. Well, am I still sharing?
There we go. I guess we're doing root cause analysis.
Great, thank you. Let's do it.
So the first thing I want to say to the group is, I love doing these things. I want to have all 50 done. And it'll take, we did a bunch last year. I'm doing a bunch this year. I'll do the ones I missed next cycle, but I'd love to see you all do as many of these as possible. It's your class. You learn a bunch from doing them, and I learn things from everyone in the class, as do we all. So don't be bashful. Unlike me, you all can still talk. So take advantage of that. Don't be scared. We're all friends here. We're all totally supportive and rooting for you. So speaking of roots, which is the worst segue of all time, let's talk about root cause analysis, or getting to the root of a problem. I'm sure we can branch off into possible solutions and leaf through different possibilities, but maybe I'm barking up the wrong tree. Be sure to tip your waiters. I'll be here all week. All right, so what does the BABOK actually say? It really gives a series of steps that you should do, which is kind of like my framework, and it's kind of like the scientific method. So what you're doing is figure out what problem you're trying to solve, or identify that you need to solve some problem that is identified by some symptom or collection of symptoms. Then you gather data on what's going on. That's a process of discovery and data collection. Then you dig around and figure out what's actually going wrong, and then you do something about it. And there are a number of approaches to that. The BABOK lists two main methods. When I get to the end, I'll talk about a third and maybe a fourth. But the main thing is there are two kind of formal ways, and these both come out of Six Sigma, which teaches you the same things. So the fishbone diagram is a way, and here are two forms of it, and here's another written out as a mind map. So what you do is work the problem from the outside in. You go from what you can see, and you slowly dig at it and find the linked chain of events that's causing the actual problem. And there are a couple of different ways to do this. So at the top level, you write down things that, say, here are potential top level problems. And then under each of those, you can break it down into secondary and deeper sub-causes or contributors, and hopefully that gets you where you want to go. So it's a question of just digging deeper. Now, it's called a fishbone diagram because you have a backbone and a bunch of flat ribs, like the middle of a fish. If you've ever cut one in half and peeled its skeleton off, or seen it in a cartoon, something that a cat likes to take away with them. And once you dig into enough of these, then hopefully that points you to the problem or the defect. They're also called Ishikawa diagrams after the Japanese engineer who came up with the idea. So one thing that happens is these outer labels have certain words in them, and there are 6 classes of things, and these are not hard and fast. You can use any categories you want, but traditionally they listed what they used to call these 6 M's: measurements, materials, man, machines, methods, and Mother Nature. Now, it's not politically correct to say man anymore, so we see people, and maybe some people get tweaked about Mother Nature, so we say environment. It doesn't make such a clever heuristic, but you know, people don't get so wacky about it. And this is just a way to make you think about as many different areas as possible. And here is just another graphical way to show the exact same information as this. And so that's all you're doing is you're going wide to think about the maximum number of things or number of possibilities. Then you go deep, so track each one down or the most plausible ones until you get to what's actually causing the problem. So one thing you know is that you cannot solve a problem until you identify it. And I will get into a story in a little bit about how I failed to do that. So on another related methodology is called the 5 whys. And that is, you think of a sweater with a bunch of threads sticking out. So you pull on one of the threads, and you can say all the threads are in the major branches you had in the fishbone diagram, right? And then you pull it, and that's 1 why. And then you say, well, now that I know the answer to that, what's the next question that leads me to why? Well, pull that thread a little more. It's like Them Bones, that children's song, right? The toe bone connected to the foot bone connected to the leg bone, and so on. And what you're doing is it's a way to make you go deep. So wide is all the different threads you have, and deep is pulling on the same thread and the threads it links to until you get to the actual root cause of the problem. Now, why this works is it's my observation, and that of many other people, is that people tend to not dig for really deep solutions. They want an answer that's simple and clear and wrong. H.L. Mencken has a famous quote about that. So you don't want to do that, and I'm guilty of it. If people are motivated to do this, it's in general in their area of expertise or avocation, like they can sometimes do it with their job function, or people with the right kind of personality kind of do it natively in their personal relationships and communication. Some people have a mechanical bent, they happen to do it in that situation, but not others. So you want to develop this capability to be endlessly curious, not accept the surface answer, be willing to dig and get all the right people involved that might know more than you do. As always, I emphasize cooperation and communication. So one of my favorite writers about software development, a guy named Chuck Dunderman, always used to say about programming culture, anytime you're working on a problem, somebody else will walk into your office at random, take one look at it, see the obvious problem, and solve it for you. And he said this behavior should be encouraged. Lure people in with food if necessary. So the point is you make use of all the expertise you have and dig deep. All right. So one thing, there are some other contexts. Let me go down here to talk about reactive versus proactive. So the way the BABOK talks about the two methods we just discussed is they are reactive. They're trying to figure out what went wrong after it happened. But if you do what's called FMEA, or failure modes and effect analysis, that's a way to be proactive. And what that's all about is you take a look at every element of a design, figure out every possible way it could fail, and then figure out ways to mitigate that, do preventive maintenance around it, prevent it from happening, or ensure that you can recover from it easily. So that's a way to proactively react to, how's that for an oxymoron, problems when they happen. And there's a link to the Wikipedia article on FMEA. There's a couple of other techniques that are in the same realm, designed for Six Sigma. There's also design for manufacturability, there's service design. There's a lot of things you can do. Simply having done the analysis ahead of time proactively also helps you set up maintenance and spare parts and whatever that you need to support the process or the product going forward. So remembering that we can do business analysis on processes like systems in your business that involve many steps, or also products. You can do it on things you're making for customers or whatever. you can also do it for environments. So every time you undergo some effort as a team, there are ways that it can fail. And these are all kind of environmental, if you think about it. So the fifth most prevalent reason projects fail is some or of the stakeholders don't buy in. If they don't support it, if they sabotage it, if they don't participate, you'll miss information, and that'll lead to bad results. If your champion isn't involved, like he kicks this thing off and then doesn't pay attention and doesn't get your resources you need, things are likely to go poorly. And I've heard executives actually running teams and supporting such efforts, and that they want to fail. It's like, let's add some appearance of busy work to keep people happy that we're doing something, but I'm gonna be over here doing what I want. Those things happen. In the long run, it doesn't lead to good results. So not identifying proper root causes, if you, like I said, if you don't understand the problem, you can't solve it. Scope creep involves taking on too much stuff in a project beyond what you agreed to. So one of the things that Agile supposedly helps you with is it says, all right, we got X amount of resources. We're gonna go as far as we can in whatever time we have or with whatever money and people. Actually, that's kind of Kanban. It's from you're supposed to develop or deploy resources sufficient to reach your goals in the time allotted. Otherwise, the methods are very similar. In waterfall, where you probably have a defined scope, doing extra stuff and not what's agreed to up front, it's great if you can do it, but it'll cause you problems in the long run. What you have to do to prevent it is say to customers who ask for extras, all right, what are you going to give up? And you have to be firm about this. When I was young, I had the impression that people would pay for a Chevy and they'd want a Cadillac, and maybe we'd give them a Buick or something like that. But don't do more than you've agreed to. And the last one, and the most important one, is if your team doesn't get along, that's the biggest reason you're going to fail. If you don't communicate, if you don't cooperate, if people have bad attitudes, it's just bad juju all the way around. And the last thing I would say on this subject is this comes from my Six Sigma stuff, and it's not in the BABOK. Same with the FMEA for that matter. And that is you work from the top down and you get increasingly focused. So you start kind of open, you narrow things down, and then you close. And I'm not going into much detail on that. Friend of mine or a mentor I used to read a lot used to say shotgun rifle scope. So you want to get more and more concentrated and accurate as you go. And that's in keeping with the other methods we covered. And that's all I have to say on that. Any questions?
Yep. A question. Can you come back to mind map? It's below fishbone.
Yep.
Yeah, how would you start working on it? Are you starting from the ends in this case, or you're starting from the middle?
From the middle. So if you notice, these 6 items around here, they're the same labels as these. And then the potential causes to dig in with each category, they're the same leads. So where's method? Algorithm, inspection, and application. So I made these at the same time. And the point is that they're the same diagram. You can do this any way you want. You can do it as a big tree. You can do it as a curly Q, whatever makes sense to you. The fishbone is the traditional way some Japanese guy did it. No reason you have to do it exactly that way.
I think Cynthia has a question.
Yeah.
Yes, I want to know, when will you use the fishbone diagram versus the mind mapping? Like, when these two tools are best used for?
They're the same. Use whatever you are comfortable with. I might write these things down as an outline and simply do it in a Word or a notepad. It's the same method. So don't get caught up on the way the picture looks. Think about what it's actually representing, what you're actually doing.
And from a Lean Six Sigma standpoint, I think one of the hardest things about root cause analysis is defining the head of the fish or the center of the octopus, whatever diagram you're using there, and narrowing it down to something that isn't so big that you can't really tell which problem you're looking at. So I think problem definition, if you're looking at a proactive approach, like this is a system, like if we're in system evaluation, you might be looking at systems and saying, why are these things coming off the assembly line late, like 80% of the time? And that might be such a large scope that you could have all kinds of root causes from all kinds of places. So I think the art of this is that I've spent like weeks with a team of people just trying to define the scope of the problem we're trying to proactively go after. And then there's, I think, the reactive approach, which you might use in a situation where you're looking at a particular defect that you found during testing, where it's like, oh my gosh, this doesn't work. Let's huddle on this and figure out your problem statement's a little more defined when you have a specific defect in testing. Whereas if you're in solution evaluation, you're going, wow, the sky's the limit. We want to make more money. That's the problem. That's probably not the greatest root cause analysis to go through. You probably have multiple problems you could drill down to. Is that kind of how you see this, Robert, or in terms of the way we apply this in different situations?
Oh yeah, I mean, if some problems are easy, but if your problem is your chair is broken, you walk up and see the leg fell off, that's an easy problem. But when you've got, you know, a bizarre folding chair made up of recombinant DNA that self-organizes according to a plan based on, you know, 20 different emergent behaviors in through 29 different computationally driven linkages, that's a way harder problem to dig into. So this really only comes into play in complex situations where the root cause isn't obvious. So down here, I talk about a situation where I went wide trying to think about everything that was related to a problem on a furnace I was working on. A company made these 800-foot roller hearth reheat furnaces that would heat up, 80-foot slabs, and they'd roll them through and roll them out to a rolling mill. From the caster, they made sure they were properly and thoroughly heated to be most prepared for rolling into thin sheets or coils. And it was doing something with the air right. And I didn't ask enough people enough questions. So I was chasing around, looking at controls, looking at air and gas supply pipes, having people cut things apart. And the problem was out of the scope. So it turned out there was a big giant fan that wasn't driving air based on what was injected into the furnace. It was actually at the base of the smokestack and sucked it out of the furnace. And because the level 2 little predictive supervisory control systems I wrote and installed and tested didn't consider that part of the operation, I never thought about it. So I went wide, but I didn't go wide enough to even pull on this thread. And I really feel bad about that. That's a giant failure on my part, but I learned from it, and hopefully you will learn from my stupidity, and you will be smarter the first time you run into this kind of thing.
Hey,
But
you know what?
honestly-
The more it hurts, the better you learn.
Oh my God.
Nothing wrong with that. That's what happens.
Yep.
I think
They
Cynthia,
had to send another engineer from Pittsburgh to solve this problem. And here's the thing. I didn't know how to ask the right questions, but nobody at the office I talked to did either. So none of us knew how to drill down, really go through an organized analysis and figure this out. So, it takes two to tango, right?
It does. It does. I'd like to talk just real quick about the 5 whys. Whenever somebody says they have a problem, always question. And a great way to start is, okay, you say that's a problem. Why is it a problem? And ask, what causes the problem and what are the impacts? And sometimes they'll tell you what the real problem is. This is the symptom that they want you to solve. If you solve symptoms, you haven't solved the problem. You got to solve the problem to resolve the symptoms. So be sure that whenever people say this is a problem, that you're really solving the real problem and not just some symptom that they have.
Yeah, oftentimes I get people coming to me saying, I need a magic dashboard, that, and I'm like, well, why do you need that dashboard? Well, I need it because I need to see this information. Okay, but why do you need to see that information? Well, because we make decisions based on that. Okay, so you keep asking why, and after about 5 whys, you get back to, well, we're losing money. Oh, okay, that's the real problem, is we're losing money. And it's because it's not visible. So yeah, doing that, not accepting what just like, because most people are problem solvers, right? They'll come to you with like an automatic solution a lot of times.
Right. People often come to you with, I want you to build this.
Yeah.
Well, you got to ask, why do you want me to build this? You know, why do you need this? What's it for? When do you need it? You know, why do you need it then? Ask all the questions. Put on your Columbo coat and, you know, hold your cigar and ask all the questions, because what that does is it gets them to provide you information you wouldn't have any other way. And you can come to the conclusion of what the real problem is. This also works really well whenever you're talking about emotional situations. You know, somebody can say, I don't want to be late. Ask them why they don't want to be late. And they'll end up with, because my mom used to yell at me whenever I was little about being late. And I mean, if you ask really quick, don't give them time to think, just get the answers, and they will tell you stuff that they did not intend to share necessarily. So be careful. This is a very powerful technique, but it's truly allowing you to get down to the root cause. Okay, Robert.
And when a very young child continually asks why, this is what they're doing. They're trying to figure out the whole world, which is a big, complex system that's way bigger than they are. So try to remember what was going on when you were 2, and you'll be fine. By the way, I included a couple of writings I did about diagnosing really strange problems, especially the first one. I put them in the chat, so I have a look at those, and at least the first one. There are some really complex problems. And I was always amazed when I worked on nuclear power plant simulators in teams of like 80, and some weird, total bizarre problem would happen in between a group of us. We were always able to chase it down, but it was a team non-trivial effort. And now let's talk about acceptance and evaluation criteria. So what I do is I just attack this from many different angles. At root, it's really simple. When you go through and talk about what you're trying to accomplish, you kind of keep track of it all this way, right? So you make sure everything you do maps to the intended use you've set up for the project, right? The requirements all relate to the what's going on in the conceptual model or the as-is state, if there is one. And you make sure the requirements therefore map to the intended use. And the design has to answer all the requirements. The implementation has to answer all elements of the design, and then every implemented item needs to be tested in one or more ways. And so keeping all that aligned is a way to say whether the solutions you come up with are acceptable. And that comes from setting up go, no go, yes, no kind of binary tests that have answers in general. And there are also, it's kind of the difference between verification and validation. So if you recall, verification is, does what I built work right, the way I intended? And validation asks the question, does what I built answer the intended use? Does it actually address and solve the problem? So the tests that are more automatable, there tend to be verification, and tests that require expert judgment are more geared toward validation. So things that say whether, yeah, this solved the problem, those are acceptance criteria. And what evaluation criteria, the difference for those is they actually say which identified solution is actually better. So you can think of, there are so many ways to go about this. I had trouble writing the article for this reason. If your project has a pre-identified like budget, or it's got to realize this much benefit and have only that much cost, that may be based on data, but it's probably going to be an entrepreneurial judgment. Or you may go through all this work, get to the design and cost it out and say, okay, we can do this, it'll work, it'll be acceptable, but we think it's too expensive for the money we'll get, or the benefit we'll get, or the time we'll save. And so that's an evaluation criteria, and at some point that's an entrepreneurial judgment. So what's an entrepreneurial judgment? It's a form of, like Jim talked about a couple weeks ago, an estimation, right? And it's really an estimations work better the more information you have, the more data you have, the more you have similar experiences that are analogous. So if Walmart, or say CVS Pharmacy, they've opened a zillion stores and they know what the demographics and the population density is to support opening a store, right? And so they have a lot of similar experience. So their estimations of what's going to work might be pretty good. But in other cases, we're doing something new, like Steve Jobs didn't know the iPhone was going to work for sure, but he had a pretty good idea, reading different trends, that if we can make something that's a ice cream bar kind of form factor that's simple and integrates a bunch of stuff, and if it's not too ungodly expensive and it's reasonably easy to use, we can probably make money on it. So that's entrepreneurial judgment. And sometimes another aspect of evaluation criteria is when you come up with multiple different solutions, and you need to figure out which one's best. One may be a lot easier to make, but one might be use cheaper materials, one might be more robust. So to some degree, you always want to consider the full life cycle of cost, right? And that's what you're doing. And that's ultimately, you can reduce it all to an economic calculation and do a reasonable and straightforward cost benefit analysis. However, the open part of that might be the benefits you'll realize, how many you sell, what the demand is. So that's the entrepreneurial part. But when you're comparing things together, if you can compare apples to apples, that's great. But what if different solutions have different characteristics that make them great? One's more robust, one's more modular, one's heavier, but one's it's heavier and more stable. The other one's more transportable. How do you consider those factors when you're trying to pick among different possible solutions? And that gets harder. And so in that case, you might want to consider a kind of weighted scoring average where you assign weights to various solution components, and then you rank them. So you multiply this times this and add everything up and do that across a lot of people and come up with some kind of hybrid score. And that is a way you might do evaluations that compare different possibilities. One other thing I talked about in here is that remember, we iterate in all these things, so we're coming to an agreement. That's a form of acceptance, right? So especially when we're doing the as is state, we'll say, okay, show us what's going on. I'll document it and diagram it. I'll show you what I wrote. You tell me whether I got it right or what I got wrong. I'll update the documentation, and we'll keep doing that until you agree that I have the correct and complete representation. Then we can move forward. So that's a form of acceptance. It's communication, cooperation, coming to an agreement, and that's the process that's akin to this. Similarly, that's iterating within phases, and then when we iterate between phases, we may go back and modify or add things that we missed based on other work we do later. I also talked about functional versus non-functional requirements. Not all non-functional requirements can be expressed in yes, no go type binary ways. Some can, some can't. It's kind of academic whether those are, and whether such things need to be verified versus validated, and whether they are acceptance criteria or evaluation criteria. So if you're aware of all these tensions and kind of yin and yang considerations, you'll have a good grasp. At the end, the main thing is acceptance is, does it meet the need? And evaluation is, which is better? And that's all I have on that. Questions, comments?
I'd like to tell you my favorite way to get acceptance criteria. I asked them, what does done look like? And as they start telling me what done looks like, I can ask them questions. Okay, you want it fast. How fast do you want it? Is every 2 minutes fast enough? And then we have really things that we can measure, because, you know, requirements need to be measurable. And then our acceptance criteria follows that.
Yeah, actually I wrote in here, I forgot about it till you said that. A good requirement will usually be written in a way that includes how it will be judged to have been met. So there's a
Right.
definition of done in user stories, requirements, whatever.
Mhm.
So you generally want to build in how you're gonna test things from the beginning. SB.
FC,
Sorry, can you hear me?
now we can.
Oh, okay. I just want to understand how to best document and trace acceptance criteria from the point we get the requirements done. So for having that, Robert, you were talking about the traceability throughout the journey.
I actually have worked on a long article about that. Requirements traceability, especially when you have very complex projects with a lot of things going on, voluminous requirements and implementation items can be complex and expensive. So I would come up with whatever moves the ball down the road. Ideally, you would be able to come up with a way to do traceability that works like this, but that's hard. I am in the process of writing up a way to do that in Jira, and other similar tools like Rally, but it's really kind of complicated. I've done this in spreadsheets, I've done this in text documents. So any way that allows you to keep track of everything that's going on in all the linkages, then that's what works. Just do whatever works. There isn't really good tool out there right now that implements this in this way.
I'll tell you how I do it. I create an outline of the requirements, literally in an outline form, and I drop it into a spreadsheet and I make the rows, and it's the requirement, the story, the acceptance criteria, and then the test. And does the test pass or fail? And that test proves that we met that requirement. But I keep it in a spreadsheet even after I move it into Jira. But I start in a spreadsheet and I don't put it into Jira or Rally or whatever until the product owners approve of everything. The technical guys say, yes, this is feasible, but that's the way I do it. Maybe there's a better way.
And no, that's a great way, and that's subsumed in the answer I kind of gave you. Also, things may be tested in many ways. So you may write a function that meets the implementation in one way, but you might write 10 automated tests for it. And so how do you, this is just in code, right? There are other kinds of validation and user acceptance tests that have to be done manually. There are systemic spoken performance tests. There are release trains. So not all these things really lend themselves to putting in a spreadsheet. But the more you can identify and track it in an organized way, the better.
Epsi, did you still have a question?
Sorry, I just had a follow-up for Thea in terms of handing over to like some of the traceability tools like Jira. So for example, like you mentioned, once you're tracking everything on the Excel spreadsheet, did you say that only after the product owner has approved for it to be implemented, you're moving it to like a tool where, you know, the testers and others can see? Till then, you're still having the Excel spreadsheet as a source of truth because it has the start to, at that point, sort of a storyline?
Yes, I keep it in Excel in my single source of truth, my tracking document, because you can see the relationship between the stories a lot easier there than you can trying to pull them up one at a time in Raleigh or Jira. It's too easy for me. Maybe I'm the only one, but it's too easy for me to lose things in Raleigh or Jira, even with tags and milestones and all kinds of other good stuff. In Excel, you can see this has to come first, this has to come second. Oh, we didn't include this, we need to add that. So put it all there. And then there's a way, and I know it's different for every application, but there's a way to actually import into Raleigh or Jira and create the story directly out of Excel. But you got to put it in the right format.
And also, I've talked about, and I haven't published this right now, I was working on it over a year ago. You can have a Jira board or any other kind of board that creates items in every one of these columns, right? So you start with the intended use item, then you go to the conceptual model item, then you go to requirements. And what you do is there's an index link, like all these have index numbers. They might be A-1 through 4. These might be B-1 through 100. This might be B-1 through 78, whatever. And you create them and then you index what they link to forwards and backwards, right? And in both directions. And you move them from, okay, I created it, I reviewed it, I've gotten acceptance for things are in different state of done this. And then you can write queries on them, say, so go through and for all the conceptual model items, which one have requirements that haven't been finalized yet? And generate a report. And there's an SQL-like function that would allow you to do that. So you can do a separate but linked Jira board for every phase. That's one thing you can do. And if you remember, I said you can do traceability through the project, but you can also do traceability as a hierarchical representation of what you're going to build, so it makes sense and is internally consistent. And theoretically, if you plotted them on a different plane, right, all the items should intersect along one line. So it's just a way to think about it. So this hierarchical representation that's logical within the project can also be captured in the Jira setup I propose for doing it through the process. So I really need to get that published.
That would be great.
May clear things up a little bit, or it may be just a bunch of Bob verbiage that
I think it'll have value just because you do it. Okay, ladies and gentlemen, we are at the end of our time, and out of respect for your time, I want to end and begin on time. Does anyone have any last questions? Okay, we will be here next week with 1 or 2 or 3 more techniques. If you're interested in being a member of our board or presenting a technique, or if you have any questions or concerns, reach out to me on LinkedIn. You can see my name is not spelled as you would normally expect a name to be spelled. So be careful of spelling, but find me on LinkedIn and I will answer you. I will see y'all next week. Thank you so much for attending. And those of you who participated, I sincerely appreciate it. I'll talk to you later. Bye, guys.